Welcome back, everyone, to the last presentation for the intermediate stage at Sub0 Online 2021. For this last presentation, we have James, who will be discussing continuous deployment of Substrate networks. James?
Thanks, Bill. Hey, good evening, everyone, or good morning if you're joining from my side of the world. It's an absolute pleasure to be joining this incredible event. I've been captivated by the speakers today, and as literally the last event of the entire program, I have got an extremely high bar to follow. My name is James Bailey. I'm the head of business development for OnFinality and Subquery, but today we're going to talk about OnFinality. Firstly, our mission is to build tools to help other teams, other builders, help them build the decentralized future faster. We build core services that many of the teams that you've seen present today use to be more efficient, to work faster, and to help us create the future faster. If you haven't heard about OnFinality yet, we are the largest external infrastructure provider for the Polkadot ecosystem. We provide infrastructure services to development teams, but we're commonly known to provide scalable, reliable, globally distributed RPC archive nodes and access those nodes throughout the Polkadot ecosystem to developers within it. So for example, we already support 21 different networks. Actually, no, this is 22 now with the release of the last Parachain auctions last night. So congratulations to the Interlay team, including each and every Parachain team in Kusama, plus more. We're a small team based in New Zealand. I apologize in advance for my thick New Zealand accent. And we're currently operating at a huge scale with over 300 million API requests to the Polkadot ecosystem each and every day. Now that's outdated. Yesterday we had our largest day yet with almost 600 million requests in a single 24-hour period. We're talking about 7,000 requests hitting our RPC nodes every second. There must be some massive event on in Substrate right now around the board. Who knows? So this is a testament really to the thriving developer community that is part of our ecosystem. They're working together to build a decentralized future. We are very proud to be part of this. We've invested huge amounts into building scalable, reliable, and globally distributed RPC nodes. This helps grow the ecosystem by reducing the barriers to entry to access a high-performance node. It helps scale existing projects in the ecosystem, existing applications or blockchain networks by providing infrastructure services that can be depended on. It assists with the testing of all these networks by providing valuable data back on the type of requests that are made, where they're coming from, and what they're making them for. All this work has made us pretty good at managing and deploying infrastructure at scale. And that's what we're here today to talk about. So, some background first. Blockchain development is damn hard, okay? There's a reason why I'm struggling to find great developers to work with us in this space. We live in a highly technical environment with a challenging domain. I don't know about you, but I've given up trying to explain what I do in a day-to-day job to my family and friends. It's very technical. It's very challenging. It's full of theoretical concepts. But we're also dealing with an environment where many errors or any errors have a high stakes and there's high risks of them, both due to the financial nature of many of our blockchains and the cost to change those chains. Obviously, Polkadot has done a fantastic job at making that cost of change exponentially lower, but there still is some there. And finally, managing infrastructure is painful, and it's the last thing that we want to do. And this is really what the focus of that today is. Why is this? Well, firstly, creating a network, a large test network during our development cycles is expensive. It takes time to manage, time that we do not have. It's also infuriating when it goes wrong. say goodbye to a productive afternoon. I don't know about you, but I've spent many times where I've hopped on AWS. I think it's going to take me half an hour to get this done. And 4 hours later, I'm still just have no idea what's going wrong, trying to figure out some tiny configuration in AWS or Azure or GCP that's just put everything behind. It's not like the old way as well in blockchain. It's not like the old way where you would just deploy your code directly to a staging server. We're different. To fully test a change in our environment, we need to deploy it to an entire network. You want to see how it runs, how it reaches consensus, how effectively the nodes communicate, and how it scales at the network level. By running your own private net, but running this large network is incredibly expensive. Running that all in a cloud environment continuously is a hugely costly expense. But shutting it down every night and redoing it whenever you need it, that's also got a cost. And that costs us in time. It's time that we don't have as an industry. It's a catch-22. Time is the most important commodity that each and every one of us have right now, and we can't buy any more of it. As a result, continuously deploying and testing changes isn't that easy. And most of us minimize this. We don't really do much of it. And when you add a relay chain to the mix, now that's just a whole nother ballgame. It's another network to manage, double the effort, double the costs, but also the connection to that. It's just, it just adds, it compounds the situation here. So one thing I want to mention here is talking about CI and CD, continuous integration and continuous deployment. It's a culture, a set of operating principles, and is one of the best practices for development teams to implement for delivering code changes more frequently and reliably. We demand it when we build in a Web 2 world. We demand it at a company that we work for using traditional tools, but it's always been difficult in our new decentralized environment due to the prohibitively difficult infrastructure management. But of course, this is what we're here to talk about today, continuous integration of Substrate networks. Today can be separated into 3 sections. Firstly, we're going to initialize and start a brand new development test network consisting of a new relay chain and parachain. This network will have a variety of validators and collators running together. Secondly, we're going to show this network running. We're going to see how OnFinality brings all the metrics together into one place, how it makes it easy to monitor how your network is running, to maintain your network and the nodes that operate within it, and to diagnose issues that may result, to connect to it as well, via Polkadot.js or any other decentralized application or any other scripts that you want to run externally. And then finally, we're going to link this up to an automated GitHub action. So I can automatically roll out updates when I change my codes and commit that to my repository. It's simple, continuous deployment of Substrate networks. All right, we're going to go to demo side. So I'm going to start quickly by setting up a CLI tool. This is our OnFinality CLI tool. I can install it using this simple command here. I've already installed it, so we'll just kind of skip through that part. Here I've got a terminal up and running, and we're going to start by looking at the OnFinality command. So onf, we have a whole lot of help here that we can then do. Firstly, I'm just going to start a process in the background here, and then we're going to explain what happened while it operates in the background, okay? So I'm going to bootstrap a new network. OnF, network bootstrap, then pick a file, and it's going to be bootstrap relay chain. I'm going to kick that off in the background. Now let's talk about the configuration file that I've used here, okay, after this command. I have it open here in my Visual Studio Code. It's a simple configuration file for OnFinality, and it allows you to set the basic information about how we're going to deploy and bootstrap this new network. It's a magic recipe. You can see at the top here some basic information like our display name, the name of the network, obviously it's for Rococo McRowface. What else would it be? It's a standard Rococo network built with the official parity image from Docker Hub. And it links to a chain spec file actually that I have just created earlier based off the original one. These are the standard chain spec files that we all are used to. It's back to the parachain. It is, the relay chain. It has got some arguments that we're going to run on each node, force authoring. And down here, you'll see the validator part. This is where it gets a bit interesting. So I've asked it to deploy 3 validators, Alice, Bob, and Charlie, using the standard input keys. And these 3 are going to be deployed all to Japan as a validator node type. They're going to be called row face validator. We've got certain information about the size of the resources we're going to deploy. We're not going to initialize them from backups. They're going to be publicly exposed for now. They're going to be protected with an API key, and they're going to have 30 gigs of storage on them. So that's my very basic configuration file. And behind the scenes, what's happening here is our CLI is bootstrapping this entire network based off the single configuration file. It's creating a network spec in my workspace in OnFinality, and we'll go there soon. This includes the chain spec file that I have created, the default Rococo chain spec file, and all the configuration that I put in there. It then is deploying 3 validators. And the first way it does is it deploys the first validator. You see up here it started with validator 0. And it uses that as a Genesis validator. This Genesis validator is used for the remaining validators to start them up. It automatically creates that Genesis validator in an unsafe RPC mode. It then waits for that to initialize, to start up. And then as soon as it gets the P2P address, the peer-to-peer address, it then inserts that automatically into the boot configuration for the remaining 2 validators and begins deploying those. And you can see that here. Finally, it restarts everything to make sure everything's all set up and the session keys are loaded correctly. Now, this is entirely automated. This is one command that I've just run that does all of this logic behind the scenes automatically. It's a complete fire and forget mode. And it's a perfect example of a repeatable set and forget process. You can do this all in our own UI in the website, or you can do it on a single command in your CLI tool. Now, I'm going to quickly just change something, go to OnFinality. We're going to log in now and have a look at this network. So back to my website, I'm going to pick up OnFinality up here. So I just got this share screen is slightly hiding my Chrome tabs. I'm going to log in to our application. This is OnFinality website and log in app.onfinality.io. And when I log in, I'm going to just go to my networks area. And we should see the brand new network spec that just got created, Rococo McRowface. That's been added to OnFinality. And now we're looking for 3 nodes. You can see here, the 3 validator nodes have been created and deployed to AWS Tokyo, and they're running. They are up to the 24th block. We can look into the console logs of these particular nodes that are running right now. When it loads, it takes some time to retrieve the console logs from the node. Maybe not right now. And you'll be able to see metrics as they come through. These nodes have just started, so they haven't really got much data, but they're currently using 3% of memory. You can see all the metrics all in one place. And of course, you can connect to them. We have our RPC endpoints here, and we have our peer-to-peer addresses that we can also retrieve from the UI. I can see how those launch configurations were done. I can look at activity logs. I can change the image size, increase the amount of RAM, or upgrade the image. And finally, I can restart, terminate, and stop this. It's all in the application. So these are running. They're up to the 34th block. They've got 2 pairs, makes sense. Now I'm going to talk about the parachain. So I need to quick change the parachain file. And the parachain file, again, is very similar to the relay chain file that we talked about. It's the same configuration structure. Today, we're going to use Karura. The only difference I'm going to quickly do, just before we explain this, is add the new peer-to-peer addresses of that relay chain. So I'm just going to copy it. I can copy it from here, or I can copy it from our UI. I'm going to paste it into this value here, which is the boot node address. And I'm going to run that command, but rather than run the relay chain, the same command that we used before, I'm going to run a parachain one. And in the background, that is going to start up. And we're going to talk about the relay, the parachain. So here we're setting up Carface. What else? And we are looking again at the standard Docker Hub image of the Acala Karura image. It is official version 1.4.1. It's a bit old, but the same things apply. You can see the same kind of config that each node will be run with. So we're forcing authoring. We're using a chain spec file that, again, I created earlier based off the image. And we've added the boot node addresses to this as well. So it knows what boot nodes to look for when it starts. Finally, again, the same thing with the validators. We're setting up 3. We're actually going to set up 3 collators. So you can see here the node types of collators. They're called Carface collator. Again, in Japan, using 30 gigs of storage. And it's very, very straightforward. It's the same kind of configuration. Now, one thing that we could optionally do is we could say we want to make these private, the Genesis validators private, and we could ask it to set up a couple of boot nodes. We can make it so it makes the Genesis validators completely private, but the boot nodes that we create and we deploy are publicly exposed, and they obviously won't have unsafe RPC methods, but you could automate that process as well using this last little bit here. So again, the same network spec, the same config, and in the background again, you have this network starting. We have created the first collator. We have deployed that. It's running. We've inserted or retrieved the P2P endpoint. We are now restarting those, and it is now spinning up a brand new testnet. And I can jump back to our application, and we can see in here, when I go back out to my dedicated nodes list, all the other Karura collators are initializing. They're getting started, and we now have 6 nodes in the space of 7 minutes. All this has been automated using a process that is one command essentially. All this has been done in the background while I've been talking to you with minimal interaction and at speed. It's very quick. So with this single command here, the single command of OnFinality Network Bootstrap, we've started 2 different networks. With this single command here, we've deployed 6 nodes to AWS, to Tokyo, around the world from here in New Zealand. With a single command, we can even script the creation of public boot nodes for a new network. With this single command, we have saved hours. And with this single command, we now have a blank canvas that we can begin building on or even testing our network with. And although I've done this with an off-the-shelf Karura image hosted in Docker Hub that I don't maintain or manage, we support most Substrate networks if your Docker image is well constructed. Here, I'm just going to come back to OnFinality, go back to the first collator. We should now see that this is started. You were up to 5 blocks on our parachain. The Karura parachain is going. The relay chain is up to 70 blocks. And I hopefully should have some console logs in here that shows that collation has kicked off. It's that easy. Starting collation, there we are. I'm going to take this and quickly show you something else. So, as I've mentioned before, before I leave this application, we do a lot of things, right? So the second part of our presentation, we've initialized and started an entirely new test network. Now we're going to monitor and manage this test network. And we're going to do that using our tools. So I have this network running. I can get the API endpoints for it. This WebSocket connection, for example, I'm going to jump straight over to poker.js. I believe it's this one. And of course, if you know, you can go down to under the official ones and you can see our name here, right? Like this is what we do. We provide RPC endpoints for Kusama, Altair, Basilisk, Bifrost, Calamari, Crust, not Crust yet, sorry, but soon, Karua, Acala, Kilt, all these we provide endpoints for. So there's publicly available ones, but you can also connect to this brand new one that we've just made using a custom endpoint. And I've copied the address from our application, I'm pasting it into Polka.js, and Polka.js is now connecting to this brand new, completely fresh Karura parachain that I have created. And from here, I can begin doing whatever I want. I can start building applications on it. I can test it. It's running fine. It's up to the 15th block that's been started by Charlie, the third validator or collator that we have. Just a few other things with OnFinality. As I mentioned, we run public API services. And you can see that here in our API services tab. We have public endpoints, but we also have free API endpoints where you can get a API key from our website. And the advantage of having this API key is you get more analytics about the number of requests that you make, the types of requests that you make, and where the traffic's coming from. So by using this in your applications, you can get a lot more insights in terms of the traffic of your applications and how people are using them. Anyway, back to our network. We can start running tests again with this Karura. I can actually deploy a new archive node. I'll just quickly deploy an archive node on our relay chain. Again, I can deploy dedicated nodes for all of our public networks, and there's many of them. Or again, I've just created 2 custom networks. Let's deploy an archive node for the Rococo relay chain. Let's call it Karura relay. It is an archive node. And it's going to be deployed into, let's say, Ireland. We'll take 4 units of node sizes, 30 gigs of storage, and that will now be deployed completely in the background. You can see here, I can improve and edit the commands that we send when that node launches. I'm just going to leave it as default for now and confirm. And that's going to, in the background, deploy a brand new archive node to the relay chain, the relay chain that I just created. Anyway, coming back to what the main presentation. So we have initialized and started an entirely new test network. We have now monitored and managed that test network inside the application. We can see it running. It's all going fine. The final step that we're going to do today is we're going to automatically deploy a new image via a GitHub action. Before we kind of go into the GitHub actions, I just want to kind of go deeper into our CLI tool. Our CLI tool allows you to do a lot of things, more so than just what I showed you today with that single bootstrap command. It allows me to view the number of network specs. I've just got a list, and you can see here that I have 2. I have one for Rococo and one for Karura. It allows me to deploy and create nodes. So what I just did before, I can create a new node using this command. I can restart or resume or stop or terminate, delete, upgrade. I can monitor and maintain a large number of nodes through OnFinality using the CLI tool. It kind of exposes everything that our web application does. You can see my 7 nodes. I've done, remember, 6 validators, 3 validators, 3 collators, and that 1 archive node I just created. And that's running, or it should be there soon. It's just starting up. I can also do upgrade. Oh, sorry. I can also upgrade the network spec. And that's what this is really about. So the continuous deployment of our network contains kind of 2 main steps. The first one is upgrading the network spec. So inside of our application here, we list a network spec, and that includes information about the network, generally coming from that config file I showed you earlier. Things like the chain spec file, where the boot nodes are located. It's a recipe for how to build new nodes from this network. That's what a network spec is in OnFinality. The second part of that is the nodes that obviously run beneath that network spec. So when we're talking about continuous deployment of upgrades to existing nodes or new nodes, what that generally entails is first upgrading the network spec by adding a new Docker image to that spec, or enrolling a new update of a Docker image to that spec. And then the second part of that is what you want to do with the network spec. So commonly you might want to do an update to all the existing nodes that are currently deployed. In my case, there are 7 out there. Or you might want to just delete the old ones and just start new ones to test how that network spec change can kind of restart an entire network. So it really depends on what you guys, or what you would want to do as customers in terms of how you want to lay out your testing strategies and your deployment pipelines. But all of that is possible through our CLI tool. So now we go back to the last step, automated deployment. So we can completely automate the deployment of this, and this is where the magic really happens. We've built a very simple wrapper for this CLI tool in GitHub, and I'll show you it here. It is called the OnFinality action release. It is a very lightweight, and we're going to be improving it, a very lightweight wrapper, specifically made to be used as a GitHub action for that CLI tool that I've been using all day. It supports 2 main processes currently, as I mentioned. First one is upgrading the image version of the node. And you can see here in the example, you can either on the sub command, you could be image add would upgrade the image version of the network spec. And then the second part is obviously the node upgrading all the different nodes within that network spec. It sounds straightforward, right? So I'm going to quickly, there's some access keys that you'll need. To get these access keys, all you have to do is go into OnFinality, go to your account, and then create a new access key. That will work. And you can paste that. I'm going to delete this after, so don't worry. And then you can obviously put that into your GitHub secrets. You use that in your command line tool. These are the API access keys to your account, to your workspace. I'm going to jump over to GitHub, and I'm going to show you the Acala GitHub repository. Now we've forked it just so we can add this pipeline to it, but it's a little bit behind at the moment. The Acala team do a lot of development, as you can imagine, but it is a fork from Acala Network's official GitHub repository for their image. We have forked it, and all we've done really is change one part, and that is in the GitHub pipeline section. So we have created a workflow, a published Docker release YAML, and this is a common workflow used across our industry. A lot of teams will have automated this already. What this workflow does is it simply, well, first creates and publishes a Docker image. It takes all the Acala code base, it builds it, and it then it sets up Docker build, logs into Docker Hub, obviously declares some variables, it builds that Docker image. It then pushes that to Docker Hub, and it will output the image at the end, image tags at the end. This is where it gets interesting. So after that kind of standard process that happens, every team kind of will do in their own different way, what we have is we have 2 remaining steps, 2 last steps. And those 2 last steps are the real key part that we want to talk about today. It's the continuous deployment part. So you have a Docker image that has been built and deployed to Docker Hub. What we do is we do the first step. We will go in, and again, this is terrible. This is just for a demo. You would never put your access keys in here. You would always have them as a secret. Yes, I know. This is just for a demo. These will be removed after. You put your access keys in here, you sign into OnFinality, you select the workspace you're using. You can have multiple workspaces in OnFinality. They're kind of like a way to group together resources and teams to organize yourself. You then pick up the network key, and the network key can be retrieved from either the application or from the command line tool as well. It's a unique ID of the network spec that you've just created. So in our case, for Karura, it would be this string, this key here. And that would be your OnFinality network key. The first step, again, as I said, we're going to upgrade the image. So we're going to add a new image version to our network spec, and that's going to be referred to by the output of the previous steps, the Docker tag that we're using. The next step and the last step is really the is how we start rolling out updates. So we've added the network image spec. Finally, we're going to perform a rolling upgrade. And this is really cool. I always find this interesting. Again, same thing, logging in with the access key, the workspace ID, the network key. What we're telling this is that we want to upgrade all of our nodes with the newer image version, but we want to do a rolling upgrade. So automatically behind the scenes here, and this is interesting, you can do this through our command line tool, you can perform a rolling upgrade of all the nodes beneath this network spec. So in this particular situation, I'm telling it to update 30% of the nodes at a time. And it will upgrade the 30%, it will wait, and it will carry on. It's a rolling upgrade, which is pretty common. And it automates the entire management and orchestration of that rolling upgrade. It's really quite smart. I can run this, but unfortunately it takes a while to build, more time than I have left. So I'm going to quickly just show you a video that we've filmed. I filmed yesterday of this happening. So I built and pushed it. It will obviously finish that push, export the image, and then it will, the first step, upgrade the image version of the new network spec, as I said. It will connect to OnFinality. It will roll out a new change, and that's very quick. It's using the same command here, OnFinality image add a new one with the unique hash and everything else. And then it performs a rolling upgrade. And you can see here, it's happening in real time, right? Like it's doing the first one, 30%. There's 3 nodes, there's 30% one. So it starts with code data 0. And then it will upgrade that or wait for it to restart and be upgraded. And then it'll carry on the remaining one. It's all automated. The whole process end to end is efficient and happens behind the scenes. And you can see it happening live here. Now that's worked. I can probably bring up console logs here as well. But you can see how it all does it in the background automatically for you. And that's the magic sauce. That is a continuous integration of all your changes in your GitHub project or Bitbucket or any other repository that you want that has a pipeline tool, where you can see how you can automatically deploy changes to an entirely new test network. So that's really the bulk of our thing. So just to summarize, what we've done here is we have initialized and started an entirely new test network live. That included both a relay chain and a parachain. We have monitored and managed and connected to that live. We've seen in Poker.js. We're ready to start testing on it with whatever other test scripts we have offline. And we have automatically deployed a new image to that via GitHub Actions. So what's next? Well, if you want to take this the next step further, you could create a brand new relay chain and parachain on each build. Each build could be a new version, right? You could use that command to bootstrap an entirely new network every time. You could deploy multiple dedicated nodes around the world, and not just in Tokyo, but Tokyo, Ireland, North Virginia, Singapore, all the other data centers that we support on AWS, Google Cloud Platform, and Azure. You can then automate the basic testing of this via scripting. We'll bring those metrics to you saying that it's running. We can bring in those console logs from all of those different providers into one place. We can give you the metrics on the CPU, the usage, the RAM. We can give you all that in one place, but you can then test actions against that next network externally, and you can see how that network operates and how it is affected by those commands. You can then tear down the whole network. I'm done. We've finished testing. Save money. I can, in one command, delete the entire network that I've just created. I can tear it all down. I'll only pay for the nodes that we run. And that's where OnFinality works, is that, adding a network spec is free. We charge on a per hour model per hour that you run a node. It's very similar to what you do in AWS or GCP or Azure today. Every time you start up a node, we'll charge you on an hourly basis. So to save money, you can run your test for an hour, and at the end of that hour, you can just tear it all down and start again tomorrow. Same way. It takes 10 minutes. And you can do many more things, all with our Cli tool. It all automates and allows you to do everything that you've seen today, the UI, via the command line tool. So coming back to our mission, our mission really, it is to help others build the decentralized future faster. It's to provide the tools that others need to work faster, to build faster, to build more successfully with confidence, and to deploy those changes with confidence, to test out changes more often, to be more confident in the integrity and performance and the quality of the network. And that's why we've been working with all the top Parachain teams for a long time, to help them test and deploy at scale very quickly, very efficiently. Because remember, time is the most precious commodity that we all have as an industry. We are all desperately racing towards the future. We just need time to do that. So thank you very much for this talk today. That's really all I have to show. We're going to put links to our demo in terms of all the scripts, all the processes, basically everything I just said in a nice, much shorter written form. We're going to be uploading that to our documentation at support.onfinality.io probably later today. So it won't be there now, but when you wake up tomorrow, I know it's quite late where you guys are, and I know champagne is ready, so I won't want to keep you from that. But tomorrow morning, hop on there and we'll have all the documentation about what we've just done today, and how you can do it as well, and how you can start deploying faster with confidence. Thank you very much. My name is James Badley. It was a pleasure to talking to you guys all today. Yeah, thanks.
Yeah, thank you very much, James. That was a very interesting discussion. Unfortunately, the champagne is going to have to wait since we have a lot of questions, if you have some time to answer them.
Yeah, sure.
So the first and most upvoted question here, is it possible to try out your service through free credits maybe?
Yeah, that's a great question. I think one thing we probably could do is do a special Sub0 free credits program. So I suggest keeping an eye out on Discord. I'll talk to the team and we can set up a small coupon code to provide a small amount of free credits, so you can just do exactly what I do today at zero cost. Now, I don't know if you saw before there, but like there's not much cost here, right? If I want to do this for an hour, we're talking about I had the spec up before in terms of the per hour pricing of our nodes, right? But they're like effectively what you do for AWS. Let me just bring up quickly what the pricing is. And it depends on how much storage and CPU you select. So if I want to deploy a new archive node to AWS North Virginia with 30 gigs, we're talking about 4 units of CPU, we're talking about 60 cents an hour. So we're not talking about a huge cost here. Obviously, it adds up if you're running an entire network permanently, 24 hours a day, 7 days a week, which is what we're trying to avoid teams doing. And this is what we're trying to demo today, is that you don't have to permanently run and maintain a test network. You can do it each and every time fresh. But yes, we will have a coupon code specifically for the Sub0 attendees in the Discord channel later on.
All right. Wow. Thank you very much, James. So our next question we have, is there support for bare metal deploys?
Unfortunately, not at the moment. We do a lot of work under the scenes to containerize and dockerize our kind of deployment strategies. We've got huge infrastructure. Our topology of infrastructure is quite large. We're running a lot of nodes. As you can see, 600 million requests each day. That requires a lot of nodes that are load balanced beneath that. So we do a lot of Kubernetes stuff, and to automate the one-click deployment processes, we don't support bare metal at the moment. We still are working towards that, but at the moment it is kind of in a Kubernetes cluster.
Okay, so sort of following on from that, do you also support Podman or Containerd as
Great
opposed
question.
to Docker images? Yeah.
I don't believe we do at the moment. That's a great question, but I think my colleagues in Discord should be able to answer that one.
Okay. All right. So yeah, as you all know, Discord is the place to ask questions that we can't get to. But let's see if we can get through some more of these before our time is up. Is there support for alerting based on the metrics from the monitoring?
Yeah,
So
we are
yeah,
working
okay.
on that. Yeah, we're working on that. So one thing we're working on, and we do this with our partners, is to allow them to receive alerts on the monitoring of their network. But we are working on improved ways that we can allow you to subscribe to events that happen here. Subscribe to, let's say, if it stalls or you run out of storage. We do automatically send a lot of alerts via email today. So we will email you, and in my email address, I've received 7 emails saying that my nodes have started. But if a node stops syncing, if it reaches the max storage, we will email you proactively. What we're trying to do is improve that. We wanted this to be the one place where you can come to monitor and maintain your network, where you can sleep easily at night knowing that it's going to be fine when you wake up in the morning. Because that's the worst part about our industry is that we never know when Elon Musk might tweet about our products and suddenly traffic goes 10 times. So that's what we're trying to do here is by kind of doing all the work on our side, we allow you to sleep easy at night knowing that when Elon Musk tweets about your new application and you get a couple of million people hitting it, it's going to be fine. It's going to be all right.
I definitely will sleep easier knowing if Elon Musk tweets about me that I'm prepared. So could I configure my own cloud infrastructure to deploy the nodes?
Unfortunately not, no. As I said, so we've got a very tightly controlled and maintained Kubernetes cluster. We have multiple around the world. But what that means is that we have to, currently with OnFinality, we have to deploy into that cluster. So part of the benefit of that is that we can better maintain and monitor them. There's advantage there that we can look after your nodes for you, and that's what we do.
Okay. All right. Well, James, thank you very much. This was really interesting, as I said earlier, and I certainly learned a lot. If you have questions, I know we weren't able to get to all of them. There were a few more, but please feel free to ask them in the Discord. So that concludes all of the presentations for Sub0 Online 2021. Just like yesterday, we will have networking for the next half hour. But you probably won't be seeing me after this, so I'm very sad to say. However, this has been a real pleasure presenting all of these different projects and workshops and keynotes, talks, all the different things that we've done. I've had an absolute blast, and I really hope to see you around at the next Sub0.